Okay, so in the last programming exercise, we used Easy Graphics as a third-party library to create some simple drawings. We're kind of carrying on in the same theme in exercise 26 by bringing in the PyLab library to actually do some numeric plots. So, obviously we know that being able to create visualizations, create graphs and charts of data, something that you're probably going to, if you're in the sciences, if you're in really in most fields that deal with any sort of numbers, you're going to want to be able to create these. So this is kind of a pretty relevant topic. So we're bringing back this rainfall example, and I'm going to start not from scratch, but I'm going to start with the code that I have created from programming example 21, where we read in rainfall data and we were able to um, manipulate or query that table. And what's important is remember that example 21 use dictionary objects to hold this yearly rainfall table. So I'm not going to use classes like we saw in the assignments, but we'll just deal with the one that was using the straight dictionary. And I want to kind of extend or replace the old functionality of the program. Instead of user typing in actual years and months, we're going to provide them with three choices for graphs of the data. So choice number one will be a plot of rainfall over a given year. So the x-axis will be months and the y-axis is the total rainfall. So really just finding one particular row in that big rainfall data table and plotting it. So that'll be the first one we do, and we'll have to ask the user for the year that they're interested in. The second one is a plot of yearly rainfall totals. So the axis now is years, all the years in the rainfall table, and the y-axis is going to be the total across all 12 months of that year. So again, that's going to require us to sort of build some auxiliary lists for that data. The third one is probably the most involved one, where we're going to plot monthly statistics about each month's rainfall over the entire time frame that the table has data for. So for each month, we're going to plot the average, the minimum, and the maximum amount of rainfall that fell in that month. So we're actually going to plot three different series on a chart. Okay, so as I mentioned, we're going to start off by just dealing with the original program. And I actually cheated a little bit because I wrote, if you look up here, I've got the table, the code that's actually generating the table. I'm doing that, right from exercise 21. I still have the ability to resolve a month from a user, although, user actually is not going to really type that in yet, so I probably could get rid of it. I just changed my main part of my program a little bit so it prints out a menu, and then it prints out, based on that, the user can choose either to quit or to, display one of our plots. And I just keep going around until they quit. Right now, I just print out that, their choice has not been implemented yet. So if I do Python 3, I get this nice menu. Says, okay, press 1 to plot rainfall over a given year. If I press 1, nothing really happens yet, but my menuing system works, right? It just keeps telling me that the choice I selected is not implemented yet. If I type Q, it'll stop. So the first thing that I want to do is plot the rainfall over a given year. And there's a lot of different ways to attack this problem. I generally find that it's easier to create charts when you know that your data is correct, as opposed to sort of plotting some data that might be wrong and you have to kind of debug it visually. That's a little bit more tricky. So I'm going to start by actually replacing this and just simply printing out a list of all the monthly rainfall data for a particular year. And of course, the user is going to have to tell me what year they're interested in right off the bat. So I'm going to start by saying year equals int input, what year would you like to plot? And then from that, I'm going to get months. And I'm going to write a function for this. So I'll say get months. And I'll pass in my year table and the particular year that the user typed in. And for now, I'm just going to print months. Right? And I can verify with that, with the actual data. Again, I've stored my data right alongside my code. If I look at that, I probably unzoom a little bit here. There's my data for all those years, so I can go back and debug that. All right, so we've got a get months function. And remember that the year table is a dictionary and the key is a year, right? So I can get the particular year just by saying year table year. Okay. Now the value that gets returned from year table year is a list of 12 items. So I want that entire value, right? I want that list. So I can do return year table year, and that should give me the list. And so let's run this. I'll say 2014. And here's my list right there. If I look at 2014, let's unzoom. If I look at 2014 and I look at the data that my program printed out, it certainly looks like it's the same. Those are the same values. Maybe I should test one other one since I never like to test special cases like the last one or something like that. But if I look at 2007, I'm seeing the same numbers. Okay, so that's good. Now I want to plot. All right, and here's where we start to, we have to pay attention to actually using a library. All right, and so if you paid attention to the module, the module that's associated with this, we needed to include two libraries, NumPy and Matplotlib, which is part of really the same overall library. So I'm going to import NumPy, and I'm going to import matplotlib.pyplot, and because of all the code examples where we refer to this as Pylab, I'll rename it Pylab. All right, now remember, you have to have all this stuff installed on your system already for it to work. If you don't, you need to go back to those the lecture module on Pylab and see how I installed that. So we've got this month data, and the concept of Pylab actually is really it's pretty straightforward. We can create a figure or a plot very simply by specifying or by calling the plot function. All right, and the plot function accepts a range that indicates how many pieces of data is going to be used. So in this case, I'm going to use 12, right? I could just say range 12. I'm going to instead, since I have month strings, I mean, obviously the number of months really isn't going to change, but I think it is a little bit more clear. I'm going to have a piece of data for every single month string. And then I've got months, right? That's my data. At that point, that's almost all I need. Let's run this and let's get rid of the printout statement. So 2007. Oops, I've got to actually define Pylab. Looks like I might have spelled that wrong. Yep. Okay, and there's my data. And if I want to just check to verify that, it seems kind of right, 2007, the first data point was 3.74, then it was 2.02, then it was 4.3, which is right here. That looks really pretty good, right? That looks like we're plotting the right data. It would certainly be nicer to be able to provide better tick marks, actually, give the month names, maybe have some titles to all this. That's something that's pretty easily done. That's sort of the bare minimum. You describe a plot and then you show it. But you can also start adding some text. So the figure method will accept some text that will be, the title of the window. We saw that in Easy Graphics as well. So we'll create a string for that, monthly rainfall for example, 2007. We can specify tick marks, X tick marks. Again, I'm going to have 12 of them. If you want to just write 12, that's fine. I have month strings. Those are my tick marks. And since that's going to be pretty large text, I'm going to make that small tick marks. Okay, we can kind of incrementally work with this. Oops. Okay, looks like I still have to work on this. List object cannot be interpreted as an integer. Yeah, so length. Okay, we're getting closer now. Looks like, yeah, so that's where I had that extra parentheses there. And there we go, and we've got a little bit better of a set of data points now. Right? If I want to add a label to the y-axis, usually kind of a good idea. Pylab, y label, and again, there's lots of additional functionality here that we're not covering all of it. Right? It's all in the documentation, right? So for Pylab, you can figure out how to do pretty much anything that you see with charts. You can develop really professional looking charts using the same library. It's just a matter of searching for the right functions and understanding what they accept as their parameters. Okay, so now we've got that one out of the way. Now we have to start looking at the second one. So a plot of yearly rainfall totals. The x-axis is the years, the y-axis is the rainfall total for that entire year. So I like to work a little inside out here again. I'm not going to worry about the charts just yet. What I'm going to start out by doing is seeing if I can print out the total for each year. Right? So I might actually have a function called get yearly totals. Right? It would expect year table. And at this point, I can just print it. Right? That's probably enough. And that's not going to be that particularly descriptive, but I can at least make sure that I can find those yearly totals, and maybe I'll add up a few, or maybe look at the original data and just make sure that I have those totals correct. So let's go back up here and write those utility functions. So I got get yearly totals from the year table. All right. So really what this is all about is, building a list. So years equals a list for, and now I can cycle through each year inside this year table and calculate the total for each one of them. So we could say for year in year table dot keys. We could say we could get all 12 monthly readings by saying year table year, and then the total is just the sum. And we can say years dot append the sum. So let's give that a shot. Okay, so I've got lots and lots of numbers. I need to make some sense out of this. I need to make sure that they're actually accurate. So I'm going to bring over, I've loaded up the actual website that I pulled this data from, and that's convenient because they already have the totals. So rather than me adding them up by hand, I can see them right there, that what the computed totals of all of this is. And I can do a quick spot check and make sure that it makes sense. So the first year was 3601. If I kind of scroll down, and I could print this out a little nicer so I could check each one, but I see 50.64, 47.85, 50.64, 47.85. So it looks like I'm calculating the right numbers, right? So the yearly totals is all there now. So that function itself now can be used to plot, right? So a lot of this is going to be exactly the same. I'm not going to ask the user anything. The difference, of course, is that I'm not plotting 12 data points along the x-axis. I'm actually plotting one for each year. So that would be year table dot keys, right? The length of that. And I'm going to call get yearly totals for the data. The tick marks will just be the actual years. And I'll update the Y label. Okay, so let's gotta fix this again. Keep messing up my my parentheses here. Missing one there. Okay. So I've got monthly up for a year. That's not, my figure is not right. So for all years instead of a given year. Almost there, I think. So line 78, we're having an argument. The dictionary keys does not accept indexing. Oops. Okay, so it looks like the PyLab doesn't really, back up for a second. Yeartable.keys returns what amounts to in Python 3 is a dictionary keys objects, which is very similar to a set. It's not a pure list and it doesn't support pure indexing. What we can do is just say create a list out of that. We don't even need to say .keys, and let's see if that fixes it. Okay, there we go. Now we've got a ton of data points here, and in fact, maybe I probably need a better solution than this, than even having these tick marks. Maybe it's even better to just leave them out. Actually, we can go through the PyLab documentation and sort of specify different spacing between the X tick marks. But right now, all of my 200 years here worth of data is all smashed together. I'll leave that alone for now, but well, you can clearly see, that we're able to plot all of these years across for a total amount of rainfall. So again, I'll leave that as sort of your own exercise to clean up those tick marks right now. The third one, plot monthly averages, min and max. So the x-axis is going to be months, y-axis is the average, min, and max, meaning there's 3 series. So I have to collect a lot of data again, and I have to plot all 3 pieces of data. A lot of this is going to be very similar. Okay, so let's do this. I'm going to keep most of the text the same. Monthly rainfall, let's say statistics instead. We're going to be plotting month to month, but we're going to be plotting 3 things. Let's say averages, minimums, and maximums. I'll keep all of this, the rest of the X tick marks. The averages, minimums, and maximums, we're going to have to actually go find. I'm going to plot one at a time. So let's just do it that way. And let's, instead of just calling it averages, let's say get averages. All right, and so that's going to return a list of 12 values, each value representing the average rainfall across all years in a given month. So I'll write a function up here, get averages. And I need to now actually go through every single month and compute the average for that month and then build out a list. So I'm going to create a month list for I in range 12. So for every month, I'm going to append month.append. And rather than trying to kind of build this all from, all in one place, I'll just say, get average year table and the actual month I. Okay, and at the end I'll return months. So get average. And so each individual function is pretty easy to understand, right? Now we'll have year table, the actual month. So get the average rainfall for that particular month. And now to be able to do that, I need to get a list of every single value for that particular month. That's actually kind of, it's very similar to the list of years data that we have, but for every year, I just want to pull out one individual value. So in fact, I can say maybe years equals a list comprehension. And I could say, well, starting back kind of backwards for every year in year table. What do I want? Well, I only want the data associated with the year I'm being asked for. So year table, year, I want to go into that year and I want to go to that month. Right? So that was going to give me a list. Each element in this list represents a year of that given month. From there, I can say, total equals sum years, and I can return total divided by length years. All right, and that'll be my average. Let's run this and correct any little mistakes we've got. Okay, so there's the average. If we pull up our listings here, this data from our original source actually does have averages as well. So it's, again, pretty nice, 3.44, 3.44. If we look at April, that was 3.72. That's really pretty close. It's a little bit off because this data has a little bit more, one more row. If we look at like something like November, 4.61, and that's right around here. So that looks pretty good. Sorry, 3.37. Sorry, 3.37, and it's falling roughly where we would expect. Okay, so now we got to get min and now we've got to get min and max. All right, how are we going to do that? Well, it's going to be very similar, right? So I'm going to say get minimums and these programs are going to start to look very similar. These functions are going to start to look very similar. I can say get minimums, same deal, but get min. maximums, get maximum. And then if I look at the get average function, well, get minimum for a particular month is actually even easier. I can just return the minimum of that list that I created. Maximum is just as easy. Okay, so let's run that. Let's see what we end up with. Okay, and running it with all three plots, we clearly have the median or the average falling right in between them. That makes sense. You can see sort of the minimum out here is June. Seems like we've had a few hurricanes probably in a few of these years where we've got a very high maximum value in terms of amount of rainfall in August. And so now we've got sort of this complete chart that we can I don't know, probably not draw too many conclusions about trends. That's probably not a great idea just from this. Probably have to do some statistical analysis on it. But clearly we're able to take a big graph of data and, in roughly in a pretty small amount of time, whip up a little program to visualize it fairly easily. If you're going to use this for like in a final production level form, you'd want to dress this up and everything. But, oftentimes we write these quick scripts just so we can generate some data real quickly. Can Excel do a lot of this? Sure. But can we now modify this and compute a lot of different statistics with it using Python? Absolutely.